Welcome Wakas, welcome Logs, welcome Wendy, welcome Zoe, Cam, Bassett, hello sir. Liam doesn't like my question. Gotta switch it up for him. Oh, I spelled or wrong. It said 2. Or 32 toucans. Welcome, Paul. Cam, you have to give a reason. You can't just say the toucans. Why would the toucans win? You got to go in depth here. It depends. It doesn't depend on anything. You got to explain. All right, let me fire up the attendance. Now it's 10:15. See how we do here. Alrighty. Awesome. I see Ty, Walker's, Zoe, Ben is here, Bassett's here, Cam was here. Logs was here. He's got some sort of stop sign dab. Stop dabbing. Is that a plea for the dabbing to stop? Crystal is here. Daffy's here. Izzy's here. Who did I miss? Kyle's here. Awesome. Hello, Jerry. Wendy's here. Lanice is here. So I'm missing Hugh. I saw Bassett, but I'm not sure I saw Batten. So if Batten could hit me up. Yalda as well. Paula and Max. I think I didn't see Paula. Yalda's here. If you guys could, if you could look at your homework from last night just to see if we any questions about that you want me to take up? So still missing Paula, Max, David. Batten is now here. Awesome. And Hugh. So if any of those guys show up, or girls, let me know. Toucans have beaks, dude. Also, they have Fruit Loops, and I feel like Fruit Loops, they could just like spam Fruit Loops at the alpaca. It has rabies, it would eat them, and it would get diabetes. All right. Let's just remind us, ourselves, not us, who we had, or what we had for homework. Let's see. Let me change what we're looking at here. I don't think flying away counts as forfeit. Yo. What were we doing? We were doing special angles. And I asked you guys to do number 4, 9, and 11. Was there any questions about 4, 9, or 11 from last night? I'll just grab my textbook. I'll be 1 second. Just grab it. I don't know where. Oh, I think I put it back in my room. 9. Okay. Yep. I'll look at that in a second. $286. All right, so it says show that tan 30 plus 30. All right, we'll just rock and roll. So for number 9, let me just go full screen here. We're back to working. That's good. I don't know what was going on here. Okay, the pen's not working though. Not everything can work. That would not be cool. All right, so for number 9, it says, I'm going to separate it. So we're going to get tan 30. This will be our left side, LS, for left side. So tan 30 plus 1 over tan 30 should be equal to our right side, which is 1 over sine 30 cos 30. So it says, show that those are equal. Okay, so I see a lot of 30s. That means for me, Bassett retracted his message. Okay, there was somebody else just messaged me about 11B anyways, though, Bassett, so all's good. What I need, though, is my 30, 60, 90 triangle. Remember, I need my 30, 90, 60. If you remember that one, the one with a 60-degree angle in it, was where the hypotenuse was 2. There was a root 3 across from 60 and a 1. It's like kind of like 1, 2, 3, but you have a 1, 2, root 3. Anyways, this is how I kind of remember it. Dumb ways of doing that. So let's see. If we do tan of 30, remember that would be opposite over adjacent. Opposite over adjacent. So I know tan of 30 is going to be 1 over root 3. And then 1 over tan 30, well, that's basically like the reciprocal, right? It's like kind of like 1 over, oops, sorry. It's like having 1 over root 3. And if you were to deal with that, that's like saying 1 over root 3 plus, and then you flip it, right? Divide those fractions, it's root 3 over 1. So you get 1 over root 3 plus root 3 over 1. We're probably going to have to put those together, but let's just do this right side here first, and then we'll see what we need to kind of work our way towards. So sine 30, sine is opposite over hypotenuse, right? So sine 30 is going to be 1 over, sine 30 is a half. And cos 30 is root 3 over 2, right? Because adjacent over hypotenuse would be root 3 over 2. So in the end here, I see that I'm going to get, this is equal to 1 over root 3 over 4, right? Root 3 times 1 here is root 3. 2 times 2 is 4. So when I finish this off, I'm going to have to flip, right? So we will get 4 over root 3. And I see how these are going to work out now nicely. I'm going to get a common denominator over here. So I'm going to multiply this to be root 3 times root 3. That's 1 over root 3 plus root 3 times root 3. I don't know if you guys remember, but that would just be 3 over root 3. And that's 1 plus 3 is 4 over root 3. So that's how we show that those two are the same. I feel like maybe I went through this step right here a little bit quickly. Just remember that that's technically 1 divided by root 3 over 4, which is the same thing as 1 times 4 over root 3. And it's just basically I'm flipping the fraction. I'm doing the reciprocal. 1 over means the reciprocal, so I'm just flipping it here. That's how I got that stage, if you were wondering. Same thing with here, right? This is 1 divided by 1 over root 3, which is the same thing as 1 times root 3 over 1, which is why I get this. And remember, root 3 times root 3, that was what we proved yesterday. Root 2 times root 2 is 2. Root 3 times root 3 is 3. All that sort of stuff. So anyways, I'll just zoom out. And that is your answer for number 9, proving that those are equal. And then I believe I had a message, I think it was 11B, but let me just double check. Yeah, it was 11B, so let's do that. 11 says, oh, that's a fun one. I might have to draw this one quickly. So remember, you can pause my YouTube channel, so pause it here if you need to get this down. If you were unable to do that, and then catch back up in a second if you had 11B down. So 11B, it says cos of this angle beta is equal to root 3 over 2. And then I'm just going to write out, I'm going to draw it. It's going to be crappy. Judge away if you'd like. P, Q, then I know it makes a 90 degree angle here at R. I've got S that tells me this is 13. Tells me this angle here is beta. Tells me this one is 45. So that's awesome. Okay, cool. So what are we actually doing? Oh, the area. Yeah. So in order to get our area here, right, what we need is the base times height divided by 2. The area of our triangle is base times height divided by 2. So we don't know the base. The base is really that length QS, right? So I'll just write in here QS, like it's the, sorry, can you see my mouse? Where's my mouse? It's the full length here from Q to S, that would be the base. And the height is like that PR, right? And then that would be divided by 2. So let's get QS. And basically we're just gonna have to worry about solving these things. So I think the first thing I'm gonna do is I'm gonna calculate, and I'm gonna look at this cos beta right here. So right now, these are ratios, so like they're fractions that could be simplified. So you might be a little confused because when you look at beta right here, I would think this is, remember, cos is adjacent over hypotenuse. So if we're looking at that then, from this angle here, right, this would be the opposite side in here. This would be the hypotenuse, because again, this is a right angle as well, right? So this would be like your H, this would be like your A, and this would be like your O in this case. So I would know, looking at this thing here then, I have like this cos beta. When I look at it, forgetting about what the question tells me for a sec, who cares what this says? I look at this and I think A, so this length is like PR. So cos beta equals our PR that we want to get over the height, which is 13. So that looks very different, right? They told me it was root 3 over 2, and I'm looking here and I see, oh, it's PR over 13. Well, it's because they're a ratio. Basically, they're fractions, and you can, like, you know, a half is the same thing as 3 over 6 is the same thing as, you know, 8 over 16, whatever it is. So this, I know it's a little bit uglier because there's a 13 on the bottom, but we just have to make sure that that PR is going to be, you know, a similar ratio. So what I'm going to do is I'm going to set this fraction here equal to this fraction because they're both cos beta. And then I'll just solve for what PR is, right? And that'll tell me that is the height of our triangle, so that'll be helpful. So if I do this, I'm going to say that our root 3 over 2 is going to be equal to PR over 13. That is going to tell me that my PR is equal to 13 root 3 over 2. Now, that thing can't be, oops, sorry, you can't see what I'm doing. Sorry, that's supposed to be PR. It got real ugly there. PR is equal to 13 root 3 over 2. That's a pretty nasty number, but I'm going to leave it as an exact value like that for now, because if I do a decimal, it's going to get rounded. My answer is going to be off. So I'm going to just leave that as that normal number. Sometimes when I do this, I try to use my diagram and I fill in my numbers. So I'm going to erase that little a in here and I'm going to write that instead. I'll write 13 root 3 over 2. Just so you can start to see the numbers, right? That way when we're filling stuff in. So we have the height now. I know that in our little formula over here, right, as I'm filling things in, I need my QS still, but I know my PR is 13 root 3 over 2. Sorry, that's ugly. And you can't see. And then that's still all divided by 2. But what I need is the base, and so I have to do that in, sorry, got to use my mouse, a little pop-up for that stupid keyboard thing popped up. So I need to figure out what QR is and RS, and that'll be that full QS. So I have to do a couple steps to do that. Here what I would do is I'd probably use the Pythagorean theorem to get this side here, and on this one here, I'd use, because you know, like from 45 degrees, right? You can use SOHCAHTOA. It's opposite over adjacent. So to get this length in here, I'd use tan, right? Tan 45 is equal to this over the adjacent side here. And then for this triangle, I would just use like 13 squared equals this squared plus this squared and solve for that. And then you should be able to solve that together. I don't think I need to do that with you guys. Probably it was just that initial step setup that was the thing that was really throwing you off. If you still get stuck, try from here, because I'm not done. You want to see if you can get that QS. I'm going to leave that up to you guys to try from here. That way I don't waste all of your time. But I think you should be able to get those last two sides, because they're just using Pythagorean theorem now and just using tan. Tan 45 is this over this. Okay, so I'll leave that right there for a second. I'll zoom in a little bit better so you can get the full picture of that question. And now you would just be finishing that up. But again, feel free to pause here or whatever it would be. I'm just going to take a drink of water and we're going to move on. Unless those people's questions from number 11 were about a different stage, or was it the initial setup? Maybe those people that had this question, let me know if that was where you got stuck, or if you already had this and you're like, Mr. Ellis, you didn't help me at all. Just wait a second for those people to hit me back up with the message. Anyways, no worries. We'll rock and roll. Liam, how about you finish it? Honestly, you guys seriously should have the skills to finish this. But I guess I can. Like, I feel like it's kind of a waste of my time and yours. I think it's more laziness, but let's look. So your 13 squared, if we're just going to do SR, is equal to 13 root 3 over 2 squared plus that SR squared. right? So that'll be your SR, and then you need to get RQ, and that is tan of 45 is equal to opposite. Sorry, 45 is equal to opposite. So the 13 root 3 over 2 over the adjacent, which is your RQ. So solve for R. Oh, sorry, you can't see that. Solve for RQ, solve for SR. Add those two together, and that's going to be your QS there, right? This side length plus this side length, and then just solve. I do not need to do that from there for you. That's enough. Okay. So if we're looking at 5.3, 5.4, some of these, 5.3 especially, was pretty useless. So you'll notice that by useless, I mean it's just like they're not doing that much information, and 5.4 was way too long. So I actually have, for today's lesson, it says 5.3 and 5.4, and then when we come back on Monday, I do like a 5.4 part 2. So basically like 5.4 was way too long and complicated, and 5.3 was way too easy and short. So I took a little bit of 5.4 and put it into today's lesson, basically. That way Monday is not a train wreck for us. Okay, so let's start this sucker then. Let me just get myself all set up here. If you guys can take out your note for 5.4. 5.3-5.4 should look sorry, something like this. It is a bit lengthy, but it's really easy in terms of like what we're filling in. There's not a lot of writing. I've got some fill in the blanks for you guys, so life should be pretty good. We'll see how far we get through some of this stuff here, and I think I don't want to. Yeah, we'll see. Okay. Let's rock and roll. A lot of this is just like fill in the blanks, but let me just get my chat set up here. That way I can see you guys at the same time. Okay. All right, let's do this. So basically, you're going to be able to calculate like the value of an angle given its coordinates. Like if I give you like the X and Y point on an axis, we're going to kind of look at not just angles, just general angles before. I think you guys had looked at a lot of angles when you were like, you know, last year, the year before, and you like looked at triangles and said, okay, this is an angle. But as you work towards like grade 11 and 12, you start to relate angles to functions, and you put angles on a X and Y axis because there's a lot of like applications that can come out of that and some really cool properties. So we're going to look at that. This should have been something you learned last year, this initial part here. We'll talk about a couple things with this, but basically in your Cartesian plane, there's actually one mistake. I don't know if you guys noticed this. I don't know why they wrote X equals 0 and Y equals 0 there, and maybe just erase that or go over it with a white ink because that's wrong, right? X equals 0 is the equation of that vertical Y axis, and Y equals 0 is that horizontal X axis. So it doesn't make sense that those were there. I'd erase them or cross them out and change it if you want it. They didn't need to be on there anyways. It's not what we're learning today. It doesn't really relate. So either way, it doesn't matter. So if you guys remember, the only reason that these things have names is so we can talk about them. And I can say, okay, what's in quadrant 1 or quadrant 2? And it makes sense. So the word quadrant means like basically sections, and so there's 4, being quad being 4, so there's 4 parts, right? There's this part here where we have like the positive X values and positive Y values. Over here, this is negative X and positive Y. This is negative X and negative Y, and so on. You get the positive X, negative Y down here. So there's different quadrants, and these are going to be very useful to have names for. So I don't know if you guys remember, this is your quadrant Q1, quadrant 1. This would be your quadrant 2. They go counterclockwise, right? Go backwards. Quadrant 3 and quadrant 4. So anyways, those are just set up like that so we can talk about it. So I can be like, okay, the angle lands in quadrant 1. Blah, blah, blah. What can you tell me about it? That sort of thing. So we just needed to give those a quick name. So there you go. Moving on. Okay, so there's a couple things we need to talk about in terms of definitions too. Today's a lot of setup in terms of like terminology. It's not a lot of like new math. Yesterday might have had some new math with those special triangles, but today's more like, okay, like we need to learn some terminology because some stuff we're doing over the next few days is a little bit more complicated next week when we learn to solve trig equations and things like that you have to know these words for. So I'm not sure what you learned in grade 10. I've never taught grade 10 math, so I don't have a full understanding of that, but I think you have maybe a basis of some of these, and I know some of you guys in grade 11 too have that. But basically, what you need to have for standard position, this means like regular angles on the Cartesian plane, like your X and Y axis. The angle has to have, and you guys know what a vertex is in a parabola, right? It's like the chin. Well, the vertex of an angle is like where the angle meets. Sorry, I don't know. I probably look like a freaking weirdo. But yeah, it's like the elbows of the angle, right? It's like where it starts from. Where's the center of the angle? So in standard position, the vertex of the angle. Hey, Katrin, you're supposed to be in your period 2 right now. Is at the origin. So that means it starts at 0, 0, right? The center of the angle is going to start right there. And B, there's a second part to this. Its initial arm is along the positive x-axis. So I'm going to draw a picture here for you. Maybe I can even use that little shape, so we can just grab one of these suckers here and just quickly draw this. Okay, so in terms of your angle in standard position, if you have X and Y here and I was to draw it, the vertex is always at the origin, right? It's going to start right in the center. And when I say initial arm, I'm going to explain that in a second. But this is your, I'll just use a third color, initial arm. And that's like, where does the angle start from? I should zoom in on that so you guys can see this a little bit better. But it's like, where does the angle start from? And then the terminal arm, think of it like terminal means like, well, I shouldn't describe that. There's only like sad ways to describe terminal, but it means where you end up, right? It means the end. Terminus is normally a word, old school word for the end. But basically, I don't know, you can draw it anywhere. This being your terminal arm, what happens is your angle is measured from the initial arm to the terminal arm. It goes around. Oops, I should write that in orange. That looks hideous. Terminal arm. So we start at the initial arm, we go to the terminal arm. Oop, looks like I'm frozen on my stream. Hopefully I'm not frozen for you guys as well. Anyways, the terminal arm. So we start, that's standard position. There's other ways, like obviously I could slap an angle anywhere, but to keep things standardized, standard position, so it makes sense, everything's good. I look a little blurry on my screen. Hopefully I'm okay quality for you guys, but it starts at the initial arm and goes to the terminal arm. I'm just gonna give you a minute to write that down, and I'm not sure because I haven't seen anybody from the homework check since. I've just had a couple people respond to me. Can you give me a thumbs up that you're still alive? In the chat or something like that, just so I know you guys are still cool, you're done writing this, all's good. All right, Zoe's alive, good, good, good. Zoe, did you guys just talk about this in Hazo's class, or did you learn this last year as well? Some of this stuff. I'm not sure how you guys learned angles last year. Joshy's alive, Izzy's alive, Yaldez is alive, good, good, good. Kyle just says, yeah, Cameron does her classic. Although, Cam, you said a new thing today. What did you say? You said something about the toucans, but then you never, it was like 3 words. It was all I got. Just as, okay, not grade 10. That's good to know. Okay, so I do have to kind of go, sorry for those of you guys that were in ASOs. I just want to make sure that I don't miss anyone that didn't take this in grade 10, right? Or sorry, that only took math in grade 10 and not ASOS class. So I apologize for those of you guys that had some of this before. Hopefully you still get it down. It's nice to have that organized note, right? And maybe there's something else that gets added to it as well. Ty says he's breathing at the very least. Okay, so there's 2 different directions here. And you might be like, Mr. Ellis, how did you know for this angle right here that it went this way? Like from the initial arm, measured around that way there. Well, that way is the usual direction, and it is the positive direction. Okay, positive always goes counterclockwise, and you always start at your initial arm, right? So you always start here along the positive axis, and then a positive angle, and by positive I mean like positive 90 degrees, because you can actually have like negative 10, negative 90, negative 1 as well. We'll talk about that in a second. But this would be a positive angle. So basically, what do we write here? Sorry, it's a bit of fill in the blank. But a positive angle is formed by a counterclockwise. I don't know if you guys want to write that in. Hopefully I gave myself enough space. Clockwise, rotation. Clearly I cut out more words than I needed to here. Rotation, and that is of the terminal arm. So it's formed by a counterclockwise rotation, and then a negative is formed by a clockwise rotation. So I don't know if you just want to write clockwise in here, and then I'll just give you 2 quick diagrams for each of those. And hopefully you guys know what the words clockwise and counterclockwise mean. Clockwise is with a clock, although I know most of us, like me as well, it's not even like some boomer comment. Like I literally hardly ever read a clock. I don't even own a clock in my house. I just use my phone, right? So basically, I don't know. Hopefully you guys still know what clockwise means. I think you kind of get that. Means like basically spinning around, although hopefully, I don't know, YouTube might be backwards, so I don't want to mess with you. I'm not going to do it on my hands. But just think of a clock going, the hands move to the right, I guess, from the top. They move to the right. Counterclockwise moves to the left. So a positive angle here, if I just quickly draw out, I don't need to be fancy here, X and Y. A positive angle here would start at your initial arm, and then the terminal arm moves like this. So this being a 90-degree angle, this is positive 90 degrees, okay? And then down here, X and Y. Again, if you have your initial arm and it goes, you can't see what I'm doing. Let me just zoom out a little bit there. A negative angle goes the other way, and that is a negative 90-degree angle. And hopefully, you kind of see that angles can have different names, right? Technically, yes, this is positive 90 degrees, and yes, this is negative 90, but could this angle not also have been measured from its initial arm, and if it went all the way around, not 90, not 180, but 270 degrees? And yes, 270 degrees is the same thing as negative 90. And we're going to learn about that in a second. But if you took your calculator out right now, and if you don't believe me, if I type in sine 90, right, I'm going to get an answer here. Actually, I think mine's in a different mode here again. Sorry. Mine's in that radian mode that I talked about yesterday. Let me just use my phone then. You guys might not care. But if I type in sine, let's clear everything. Sine, we'll do negative 90, right? Sine of negative 90. I see that it's going to be negative 1. And I think that makes sense because, if we're thinking about our angles and all that sort of stuff. Remember I told you it's on that unit circle. It'd be the y value for sine, so down here at -1. And let's also try sine 270. You can also see, as long as my thing doesn't freeze, that they're both -1 there, right? They're both -1. So in general, yeah, they are the same thing. Hey, Max. Welcome, man. Sorry, let me just adjust the attendance here. I don't even know if I submitted the original one. Max is here now. Did Paula ever show up? I'm not sure. Paula, are you here? Or David or Hugh? I don't think either of those people showed. Don't think so. Okay. Save that. Okay, where are we? We are here. Okay, so there's your positives and negatives. Hopefully that kind of makes sense. Let's just quickly, you guys should be able to do this. See if you guys can crush these angles right now. You should have the skills. So what are these things? Well, this one, right, if we always start at your initial arm and then we measure, this is in the positive direction, it's heading this way. So this is gonna be positive 90 degrees. So I just know that is just straight up gonna be 90 degrees. My screen is very blurry. Okay, sorry about that. Hopefully you guys can. I wonder if you pause me, Yalda, and let me buffer, if that might help. And just be a little bit behind. Oh, it's better now. Okay, yeah. I think even I saw that I was a little bit blurry at one point. Sorry, it might be my internet today. Anyways, my dad's down here, so he might have been doing some online class stuff as well. So sorry, that might be the issue with my internet. He's here for the weekend, helping me fix my basement up. Okay, so this one here, it's important that you look at this and see this little thing says 40 degrees. But that's just that little bit in here. Like obviously if we're looking, that whole thing is not 40 degrees, right? I gotta kind of count as you go around. So here what we do is I know that from this initial arm, we're heading counterclockwise. So I know this is gonna be positive, right? If I follow this arrow, right, it goes from 90 degrees and then a whole half circle would be 180. And then it says this little chunk in here is 40, right? So you've had this bit up to here would have been 180. Think of it like I always think like snowboard tricks or skateboard tricks. 180 is like half a spin. It's like a backwards flip. So Kyle's totally right. It's 180 plus that little 40 in there. So in total, it's 220 degrees. And because we're heading in the counterclockwise direction, it's positive. Okay. Gnarly dudes. This one here, this thing is heading in the clockwise direction. So it's actually gonna be negative, right? If we went counterclockwise, like we started at your initial arm here and we went this direction, I'll just draw it. This would have been positive, but remember this way is negative. So it's asking us to measure the one that is given. So when we look at that, we actually need to think negative. So what do we do then? Oops, sorry, dropped my pen. Well, it's close to minus 180, right? Basically from here, if you went around halfway, that'd be minus 90, right? Like 90 degrees in here. But then if we start at the initial arm and go halfway, flip backwards, this would be minus 180 here. But then we've got another 90 degrees. So it's actually minus, right? This is minus 90, and then there'd be another minus 90 here. Sometimes that helps people. And that's minus another 90. So there's three negative 90s. It's actually negative 270 degrees. Negative 270, bro. How sick would that be? You guys should start doing that. All you guys that are out there ripping your skateboards and snowboards, you know, next time you guys do a ski trip like next year or something like that. Next winter, you could be like going off a cliff and go, "Oh, nice negative 270, bro." Anyways, I hate myself sometimes. Let's look at this. Which direction is this heading? I honestly can't even tell, but here's the initial arm. Right, here's the initial arm, and it looks like if I'm following, this must be the start, right? So that's going counterclockwise. So we ran around one time, right? This is going a positive direction because we're going counterclockwise, and then we're going around a second time. So one would have been 360, right? But then around a second time, 2 360s is 720, bro. That's 2 full spins in the snowboard. And then we have an additional 30 on top of that. So what was the total? Well, it was 2 360s, which is 720. But then we're also gonna add that little 30 on the end there. So 750. Sweet 750. I wonder what like the world record for going off a jump in terms of like 360s is. Like how many times people have like spun on a snowboard. How many degrees? I have no idea. That'd be kind of interesting. Somebody Google it. Okay. Are we cool with that? I'll just leave that up there for a second. Hopefully you guys can get that down. Any questions about this content? Give me a thumbs up if you're good, or be like, yo, I don't understand. You're weird. 1280, is that the max, Benny? 1280, eh? That's nasty. Or if you guys feel like being real nerdy, you could tell them in radians, and you know all that pi stuff? Well, 360 degrees is the same thing as 2 pi radians. So you could, next time you see somebody do a 360, be like, yo, sweet 2 pi, bro. Anyways, that's like your nerdy tip of the day. If you want to sound like more of a nerd, there you go. Some of you don't need help with that, though. Me neither. Sorry, that was an insult to myself, mostly. Okay, let's rock and roll. Probably most of you guys are skiers, though. Is anyone actually snowboard? I snowboard, I do not ski. Mr. Ellis, for C on the note, don't you measure the angle where the angle sign is? C on the note, let me just see where C is. Oh, so I see what this person is saying. Let me just show. I only do green hills, bro. Okay. So somebody was saying, don't you just measure where the angle sign is? No, it's kind of confusing, I know. This thing here, that's the angle that we're measuring. This is just the name. Like, where do they put that thing, right? They could put that thing anywhere. It's just like, that's the name of that angle. This one also, right? It's just like, that's the name of this angle. Like, they don't know where to put it. So it's not like you're only measuring to there. You're measuring the full arrow. Like, there could have been, like, that arrow doesn't need to be there, right? And then you just measure the angle itself, and then you could go in the positive or negative direction. But because there is like the thing there, they're actually wanting you to measure it from here to here. It's just them giving you direction like that. So hopefully that makes sense. Okay, so number 4, coterminal angles. Okay, so basically, you might have been a little bit confused because you might be like, why the heck am I looking at this 750 degrees when like this terminal arm to this one here, it's only 30 degrees apart. Like, why do they care about those things being all like the way around like that? Well, basically, coterminal angles are the word for like, oh, this is dumb. So coterminal angles are basically angles. Sorry, one sec. Get my pen out here. That are angles in standard position that share. Can we zoom in on this and say share? Let me use red again. That made things stand out a little bit better, didn't it? And they share the same terminal arm. So meaning that they end in the same spot. So what does that mean? Well, you know that like crazy like negative 750 one we did up here? Well, this angle right here, it is coterminal with 30 degrees because they send, like if I just said, oh, that's 30 degrees, then that would be like, you know, the same angle. They share the same terminal arm. And that makes sense because again, like I could take my calculator out and if I did sine 30, let's clear everything so you guys can see this. Hopefully you can see this, sine 30. And I also did, here, one sec, quickly. And I said that's equal. You're going to get sine 30 is equal to 0.5, right? But if I did that sine 750, same terminal arm, right? They end in the same spot. And I also press enter on there. Because they're coterminal, they end in the same spot. They give you the same value. So they're actually equal, which makes sense. It's just like I'm just trying to teach you, like if you have something 750 and they end in the same spot, they're going to give you the same value, and that's what that means. So that's the benefit behind this. So let's get out of that full screen. I just wanted you guys to be able to see my calculator a little bit better there. Okay. So back to this. Looking at this then, if I just drew you guys like a little crappy example here, let's just quickly do this. X and Y, something like that. And I said like, okay, here is your initial arm. So they obviously have the same initial arm. And then maybe I look at a terminal arm like this here, right? Well, this angle here, and maybe let's do this one in blue, I guess. No, that's ugly. Orange. So this angle theta, and if I take another angle, let's just use this gray one here, and it goes, you know, even backwards, or let's just pretend it goes all the way around once, but still ends in the same spot, and that one's called beta. It's just another, normally they use Greek letters for angles. I know it's kind of dumb, but that theta and beta would be coterminal because they end in the same spot. So they're going to have equal trig ratios. If you do sine of those, cos of those, tan of those, whatever that angle is, they'd be the exact same. Okay, so here's a kind of question that I could ask you to do. I'll just I'll zoom in on that for a second so that way you guys can maybe see that a little better. I don't want to like, I feel like I used to be better at pausing and letting you guys write stuff. And I've been worse at that lately. I don't know how you guys are dealing with it or if it's just stressful. I don't want this to be stressful. If I need to slow down, you guys just got to let me know. Okay. So this one's kind of already filled out for us here. But like if I gave you guys a question. Okay, thanks, Cam. I'm not sure, like I know guys like, I feel like Ben has multiple monitors, so Ben's got a really good system, I'm sure, where he's got the video on one screen and the note on the other, right? So he can write. But I'm not sure that everyone has that system. I think the Walkers are just sitting on a couch, so I highly doubt that they have dual monitors sitting on the couch. But anyways. Okay, so basically here, how do we get coterminal angles? So if I say, here's 150 degrees, tell me a couple more angles where I'm gonna get the same value, right? If I think about 150, I want like, you know, an angle that lands in the same spot. Well, how do we do that? Well, basically all you do, Paula's having a problem logging in. Can somebody help me out? One of Paula's friends. Can Paula send, because she seems to have Wi-Fi, can you just send the link of the YouTube stream to Paula? If somebody could help me out with that. That would be fantastic. Or any of you guys. You guys all have her in Teams. She seems to be able to message me in Teams, but I don't think she could get the stream off of Edsby. So if anyone, can somebody help me with that? Somebody send Paula while I keep teaching. That'd be great. Paula, not Paul. Oh, Paul doesn't have this part of the note. Oh, sorry, Paul. Weird. Okay, so for you, Paul, Paul, there's not like... Thanks, Yalda. Okay, thanks, Kyle. That's real random. Let me just quickly then, Paul, I'll just copy this. Oops. Paul. All right, Paul, if that doesn't fix it, let me know. But I did send you that thing in there. So let me know if that helps. Hey, Paula. Awesome. Welcome. Okay. I totally forget where we were, guys. Oh, I went into my answers. Sorry. From previous years. Where the heck did we get to? Okay, so yeah, we were talking about those coterminal angles. So this is just an explanation of how you do it, but you guys could come up with some more. I wonder if you guys could come up with a fifth or sixth one. So you see here, like if I take 150 and I take my calculator out, right, and I say like sine 150, that's going to be the same thing as if I like add 360 to it, because what's going to happen is it's going to land up in the same spot, right? This one would start here, go all the way around and land back there. That's number one, right? Number two is like, okay, well, instead of that, you don't have to draw that. It's going to get messy. Number two says, okay, instead of like going through here and then adding 360, you add another 360 and you land there as well. But so it also makes sense, like you could come up with another one where you don't just add like 360 once and then twice, maybe even a third time, and they all land up in the same position. You can see how that pattern happens infinite times, right? The other way of doing it, you see like 3 and 4 here, it's like, okay, well, I have my 150, right? I went to 150, but then after I get that, I subtract 360, and that's going to tell me what this angle is. So that really would be 150 subtract 360. It's going to give me this value in here. It'll be a negative angle, and that is going to be negative 210, right? If this is negative 180, makes sense that this would be 30 more, because 150 plus 30 would be 180. So this is negative 210 in here. And then what I could do is I say, okay, well, instead of taking 150 and just subtracting 180 once, 360 once, I'm going to go around again and subtract another 360 or another. So basically, if you have an angle and you want to find a similar value, the rule is just add or subtract 360 as many times as you want, and then you'll get an exact value. You could subtract 3 360s or 4 360s. I could take my 150 and subtract 90 360s, and that would be the right answer on the test. Or assignment or whatever it would be. So if you feel like being a jerk to me on a test and you need me to check something that's really difficult, do that. Mess with me. Because you'd have your 150 and you'd be like, it's the same angle, Mr. Ellis, but like I would never, like I would have to guess and check and divide by 360 and it'd be annoying, but it'd be the right one. It'd work out. So that's what this is saying here. In general, a coterminal angle is any angle where you take that original angle and add some number times 360, and it says number is an integer. That little I should actually be a Z, shouldn't it? Stupid. Whatever, it doesn't matter. You guys get the point. Okay, we are at 11:07. I'm not going to finish this note today, but let's just do up until... I won't do this bit. Okay, I'm not going to do down from here. We'll stop there. So we're actually doing pretty good. So a principal angle is like, you might be like, okay, like why do I care? Like I see 150 here, right? Like why do I need to know these other angles? Well, there are other like angles where you could solve and get the same answer for like the trig ratio kind of, and that'll make more sense later on. But the one that you kind of care about the most is the principal angle. And the principal angle is the smallest angle in that set. So if we're looking at all of these and I say, okay, you have 150, 510, 870, negative 2, they're all the same angle, right? These are all the exact same, they end in the same spot. They're coterminal. They all end here. But what is the principal angle? Well, it's the angle, right? None of these are between 0 and positive 360. I know this is between 0 and negative 360, but the only one that's between 0 and positive 360 is at 150. That's the first principal angle. It's the most important one, really. So the principal angle is the smallest positive angle, basically is just the angle that you see between 0 and 360. So that is your principal angle. It's the first angle, the first one. Okay, so how do we get principal angles? Well, what you do for something, so PA stands for principal angle, right? If I give you 1,000 degrees, okay, and you're like, holy smokes, like how can I like simplify that? Because that's a really big angle. It's actually okay to subtract multiples of 360. So that's how I would do it. I would take my calculator out and I would say, all right, how many times is 360 going to 1,000, right? If I take 1,000 and I divide it by 360, like what's it mostly, how many times is it gonna fit in? It won't fit in 3 times, right? Because that would be 333. 1,000 divided by 3 would be 333. So it's actually only gonna fit in 2 full times. And so what I would do is I'm gonna take my 1,000 and I'm gonna subtract, I'll do this and I'll leave it so that'll be our final answer. I'm gonna take my 1,000 and I know that it fits in 2 360s. I'll know I get the right answer if my final value here, when I take 1,000 and I subtract 2 360s, if my number is still bigger than 360, I made a mistake, right? But my answer is 280. And remember that a principal angle had to end up between 0 and 360, and 280 is, right? So I know it fit in twice. So I know I've got the right answer if my angle falls between 0 and 360. Negative 460, obviously I want to get a positive value for my principal angle, so I need to add 360, right? We need to add 360 to get this back up. So I know basically if I take negative 460 and I added 1 360 to it, that wouldn't be enough, right? I would still be at negative 100. So I'm actually going to have to add 2 360s, right? And if I do, I should have just done, this will be fine, but anyways, negative 460 plus 2 360s, we're going to get 260 in the end. So that's the principal angle. So it's basically just a way of simplifying an angle because they're really the same thing. That 260 and negative 460 and that 280 and 1000, they end in the same spot. They're coterminal, right? Because we've added or subtracted some number of 360 to get the same one. So basically, if you need to get that like coterminal angle, you basically just keep like adding or subtracting 360. Right? Just keep adding or subtracting 360 until you end up where you need to end up. So you keep adding slash, oh, you probably can't see where I am there. Sorry, one sec. (360 degrees) until they land between 0 and 360 there. Sorry, my note got a little messed up down here too. It should be angle between. Nice. And so one last definition, okay, and then I'll leave you to it. It'll be really quick. I won't do any of this stuff. And these are easy examples. So we're almost done, I promise. Then you guys got the weekend. Life's good. Someone just asked me, are you just guessing the number of 360s? Well, I didn't have to guess technically. Like if you guys wanted to, just take 1,000 in your calculator, subtract 360. Oh, it's 640. Okay, so I did 1,000 subtract 360 was 640. So that wasn't small enough. So what I would do is I would subtract another 360. Now I'm at 280. finally that's in the right zone. So I would just keep subtracting or adding 360, just one at a time. If you don't like the whole like how many times does it go in, just keep adding or subtracting until you get a number between 0 and 360, and then you'll be good. Okay, so the related acute angle, this is our last definition. The related acute angle is basically the angle between the terminal arm, where it ends, so you can write terminal arm in here, and the x-axis. Terminal arm and the x-axis. And so what that means is that the related acute angle, this is one that is more important for solving things. It is not in standard position anymore. Basically, this is no longer going to be looking at something. It's more like analyzing things in standard position. So we'll talk about that in a second. But basically, it's going to be between 0 and 90. And the reason for that, and I'm going to show you a couple examples below here, but it's going to be a very important angle when we solve trig ratios coming up on Monday. So this one here, let's do example 4. We're almost there, I promise. And then I'll just have you guys do like, I don't know, a question or two. Not a lot, because I don't want you guys to have homework. It's the weekend. I want you to enjoy. If we look here, this angle, right, 100 degrees is the principal angle it is positive, it's in standard position, right? Positive, it's in standard position, all of that stuff is true. And that's really the main angle here. But what I need to know is the related acute angle. And again, we'll talk about this basically on Monday, why. But it's the angle between, this is your, again, remember, this is your terminal arm. I'm just going to write that in red. Terminal arm. And I should write the closest x-axis. Maybe add that to your definition. Closest x-axis. Because what that is, sorry, I'll leave that for a second. That's now this angle in here. So you look from the x-axis, it doesn't matter the direction. The related acute angle is always between 0 and 90, so it's always a positive number. It's always positive. It's just, you look at the x-axis and you measure, okay, how far is that? Well, if I know a full circle is 180, right? I know a full circle is 180, and then this part here is 100 degrees in here. Well, that means what's left over, right, between here, this little related acute angle would have to be 80 degrees. So our related acute angle, RAC, is 80 degrees. Let's just do a couple more real quick. Just let you guys get that down. Remember, I said today's all about definitions, which might not make sense and might be like, this is useless. You might always say that about math. But these definitions are going to help us with the next couple days. Next week, obviously. Okay. Related acute angle here. Remember, you look at your terminal arm where it ends up, and it's the closest from the closest x-axis. So I look here, closest x-axis, right? Well, that full circle is 308 degrees. A full circle is 360. So what's going to be left over? Well, I do 360 minus 308, right? And that is going to be 52 degrees in there. So our related acute angle is 52 degrees. And again, that 308, like I know I didn't write it again, but this is just me describing it. That 308 is the principal angle. And I want to know what the related means. It is related to 308. It's a different part of it, but it's the related acute angle. It's always going to be acute. Remember, acute means between 0 and 90. So the related acute angle is 52. I don't know. Should we just do a couple more here? This one here, this 55 degrees, right? The terminal arm is here. What's the related acute angle? Hey, that's easy because it's the closest x-axis is right there, right? So this one, the related acute angle is actually the same because it's, you know, it's already less than 0 and 90. It's 55, so that's pretty simple. That one already was nice. Can you do D? Absolutely, I can do D, Batten. Look at that thing. It got messed up, didn't it? My bad. X-axis. Let's draw our principal arm on there and our terminal arm. And clearly, a lot of stuff got deleted, but there was the minus 105 up here, so I know that's minus 105. So again, related acute angle. Remember, you look at your terminal arm, which is this one in here. T for terminal, maybe, I don't know, whatever. T for terminal. We just take that terminal arm and we're just looking, okay, from the nearest x-axis, that'd be here, right? Nearest x-axis, measure there to there. Okay, well, technically, right, the full thing here would be 180 degrees. It's gone back 105, so what's left over? Basically, just take that 180 and subtract that 105. What's left over? Well, 75 degrees, right? There'd be 75 degrees in there. So that related acute angle there, this sucker, 75 degrees. Normally this would go a whole 180, right? That'd be half. But we're not going all the way to half, we're just going to 105. So what's left over? 75 degrees, right? Yeah, that's good. Nice, nice, nice. We'll just leave it there. Let me just see from those ones that I had at the top there. Oops, sorry, you probably can't see what I've wrote. I'll just see if there's anything you can even do without that last bit of the note. There might not be everything, but we'll just see quickly. 5.1, no, we did that. 5.2, 5.2. No, we're on 5.3, right? 5.3 and 5.4. Let me just go back up to the top and remember. Why isn't it minus 75? Because, Paul, remember the related acute angle is always positive, and it's always just an angle between 0 and 75. So the related acute angle is just a name for something, and it's going to be important that you always have that value as a positive angle. Like, we're not measuring it, you know, based on direction. Oops. The related acute angle is not based on direction. It's really just how far, or how many degrees is the closest x-axis from your terminal arm. So the related acute angle is always a positive number. Just by name and definition. Always positive. Sorry, I just can't remember exactly what page. I think it was 299, so we actually skipped ahead a little bit here. And I had you guys looking at one. Okay, you're not going to be able to do 2 yet. Okay, that'll be something that we do a different day, so just scratch out 2 for now. I'm not going to be able to do 3 either. Might have lucked out, homies. I think you might just have to do number 1 for now. We're not going to be able to do any of those other ones. So just do number 1 if you can, and that would be lovely in your next 10 minutes, and then you should have no homework for the weekend. That'd be great. Cool, cool, cool. Hey guys, I'm going to stick around for a minute to see if you have any questions. I see you have a couple Teams messages here, but for the most part it was like some definitions type things. Yeah, I just got a couple things there. I'll just fix Paula in the attendance. Maybe what I'll do is I'll just pray real quick. I don't do that a lot with you guys, but we might as well just pray off into the weekend there, and then I'll let you all go. So let me just bow our heads if you want with me, and then we'll rock and roll. God, thanks so much for today. Thank you for each and every one of these kids. God, it's so fun to see their humor and their goofiness through different messages in the chat. Thanks for the opportunities that we had last week to get together on Zoom and hear their voices. God, please let these students know and allow them to feel that it is true that they are indeed missed and loved, and that they hold a special place at our school, and that they belong, and that we can't wait to get back and see them, whether that's soon this year or next year as well. God, we're so thankful for each and every one of them. What a fun time to have them in class, and the memories that we are missing now. God, allow us to continue those and build off those, and still have great memories through this online experience as well. God, we ask that you be with them through their weekend, that they be able to relax and do things a little bit differently, and find some joy and find some peace through you. In your name we pray. Amen. All right, home slices. Have a good weekend, eh? Take it easy. Just do that number 1 for me. I know that's kind of it's too bad. A lot of those questions just you can't do right now, unfortunately. Anyways, you guys have a great weekend, eh? Much love. Take it easy. Take it easy. And I'll just stick around for a minute. If you guys have any questions other than that, you are free to go. So rock and roll. I'm going to fix you in the attendance right now too, Paula. Sorry about that. I had a couple people message you guys. See you, Cam. See you, Zoe. Message you that link. Hopefully you didn't get spammed with like a million. Oh, sorry. I don't have your guys' chat open. You guys saying something? See you, y'all. Have a good weekend. All right, I'm going to end her, homies.